Hello, third graders. Hope you're all doing fine. Today we have a new math lesson with the title Same Perimeter, Different Areas. It is lesson 11.9. By the end of this lesson, you will be able to compare areas of rectangles that have the same perimeter. But first, let's check on your prior knowledge and ask you, what is perimeter? Do you recall what perimeter is? Yes, you're right. It's the distance around a figure, as you can see here. So for each of these rectangles, the blue line in the first one would show you the perimeter. The green is the perimeter for the second rectangle, and the purple is that of the third rectangle. And remember, to find out the perimeter of any closed figure, you need to add up the length of all its sides. How do you find the area of a figure? Yes, exactly. You count the number of unit squares needed to cover the figure. Just like in this example, it is all the squares that make up or cover that specific given figure. Now, think about a rectangular garden. Which would you use to find the amount of fence needed to go around the garden? So what do you think? Would you look for the perimeter or the area? Of course, perimeter. You're absolutely correct. Now that we've checked your prior knowledge and refreshed your mind, let's start with unlocking the problem. Toby has 12 feet of boards to put around a rectangular sandbox. How long should he make each side so that the area of the sandbox is as large as possible? Remember, whenever we have a word problem, we first spot the keywords that help us answer the question. So Toby has 12 feet of words. These 12 feet would be put around a rectangular sandbox. Since I have the word around, this means that the perimeter is 12, and the greatest perimeter Toby can make for his sandbox cannot exceed 12 feet. That is actually 12. Now, let's read the question again. How long should he make each side so that the area of the sandbox is as large as possible? So basically, the rectangular sandbox must have 12 as perimeter and must have also the largest or bigger area possible. This means we have to try out different ways of shaping or drawing this rectangular sandbox, then choose the one with the largest possible area. Let's start with possibility 1, using the square tiles. So this is sandbox 1. The width would be made up of 1 foot and the length 5 feet. Could it be considered correct? Yes, it is correct so far. Why? Because if we add up the length of all sides, 5 plus 5, that would be 10. 1 plus 1, 2. 10 plus 2 is 12. So yes, I'm meeting the required criteria. This sandbox has a perimeter of 12 feet. Another possibility would be having this rectangle. Don't you think that this also could be an answer? Yes, it can. Why? Because having 2 feet as width and 4 feet as length, I will end up with 4 plus 4, 8. 2 plus 2, 4. 8 plus 4, 12 feet as perimeter. So yes, sandbox 2 also has 12 feet as perimeter. So it could be also the correct one. Are there any other choices or any other ways of drawing and labeling this sandbox? Well, yes, there is. I could also draw it this way, having 3 feet for width, 3 feet for length. I would add up all the length of all sides. So 3 plus 3, 6. And 3 plus 3, 6. 6 plus 6 is 12 feet. So again, this third sandbox also have 12 feet as perimeter. Well, now I end up with 3 sandboxes. Which one is the correct answer to this problem? Let's figure it out. So these are basically the 3 sandboxes I have drawn. Sandbox 1, sandbox 2, and sandbox 3. Let's find the perimeter and the area of each of these rectangles and then decide on the correct one. So sandbox 1, the perimeter is 5 plus 1 plus 5 plus 1. That would make 12 feet, which is correct. This is the criteria given in the question. What would be the area? It would be the length times width. 1 times 5 is 5. For sandbox 2, we have 4 plus 2 plus 4 plus 2, which makes 12 feet as perimeter. Now, what about its area? Remember, we learned that to find the area of any figure, we can use either multiplication or repeated addition. So you can either say 4 plus 4 equals 8, or you could say 2 times 4, and that would give you the area 8 square feet. Now, what about sandbox 3? As we mentioned earlier, we need to add up the length of all the sides, which makes 12 feet. And the area would be 3 times 3 equals 9 square feet. Now, I want you to recall the problem yourselves. What did they ask us for? They asked for a rectangular sandbox having 12 feet as perimeter and the largest possible area. So can you please tell me which sandbox would meet the given criteria? Yes, you're completely right. It is sandbox 3. Why? Because the area of sandbox 3 is the greatest. So Toby should build a sandbox that is 3 feet wide and 3 feet long. I want you to take a look at the boxes or sandboxes again. What can you observe? Let's try to think critically. Can you tell me what kind of conclusion you can draw? You have again 3 sandboxes having the same perimeter but different areas. What can we tell about the relationship between area and perimeter in this question? As you can see, the skinnier rectangle, which is that of sandbox 1, have less area than the fatter one, right? While the fatter rectangle have more areas. So whenever you have to compare rectangles, even without doing any calculations, you could tell that the skinnier rectangle would be the one with less area, while the fatter one would be the one with the largest or biggest area. Another question for you. How are the sandboxes alike and how are they different? Can you tell? Yes, you're of course right. It's very easy. All 3 rectangles have a perimeter of 12 feet, while they have different side length and different areas. That's our lesson for today. I hope that you've all understood it and assimilated well. Remember, if you have any questions, do not hesitate to post your questions, and I'll be more than happy to answer all your queries. Take care. Bye bye.